Hi, this is the read aloud for Chapter 2, Lesson 5, Metamorphic Rocks. I apologize in advance for any background noise. My learning environment is a little bit different today, so please bear with me. Rock dough. Misconception, rocks do not change form. Did you know that the heat can change a rock's form without melting it? To understand how, think of what happens when you mix eggs, sugar, baking powder in a bowl. When you bake the raw dough in a hot oven, the dough changes into cookies. Heat can change rock too. If hot magma or lava come near rock, the heat can bake the rock. The ingredients in the rock, the minerals, may not melt, but the heat can still change the rock into a new form. What is a metamorphic rock? You may be surprised to learn that heat can change rock like a hot oven changes raw cookie dough. But deep inside the earth, both heat and pressure are much greater than on Earth's surface. When great heat and pressure are applied to rock, the rock can change both its shape and its composition. Key fact, any rock that forms from another rock as a result of change in heat or pressure, or both heat and pressure, is a metamorphic rock. Turn to page 77. How metamorphic rocks form. That is the coolest rock ever on the bottom of that page. Metamorphic rock can form out of igneous, sedimentary, or other metamorphic rock. Many metamorphic rocks are found in mountains or near large masses of igneous rock. Why are metamorphic rocks commonly found in these locations? The answer lies inside the earth. The heat that can change a rock into metamorphic rock can rise through the crust. The high temperatures of these pockets can change rock into metamorphic rock. Collision between Earth's plates can also push rock down towards the heat of the mantle. Those are all ways that can change the rocks. Very high pressure can also change rock into metamorphic rock. For instance, plate collision causes great pressure to be applied to rocks while mountains are being formed. The pressure can deform or change the physical shape of the rock as shown in figure 1. Also, the deeper that a rock is buried in the crust, the greater pressure on the rock. Under very high temperature and pressure, or both, the minerals in a rock can be changed into other minerals. At the same time, the appearance, texture, and crystal structure of the minerals in the rock change. The rock eventually becomes metamorphic rock. Plates are underneath the continents of the hard part, and sometimes they move and crash and they build up, like we learned about building up constructive and destructive forces. So that's what they were talking about there. We have a very cool picture of granite, genesis, quartz, and sandstone. They get changed under heat and pressure from one to the next. How metamorphic rocks are classified. While metamorphic rocks are forming, intense heat changes the size and shape of the grains or mineral crystals in the rock. Extreme pressure squeezes rock so that the mineral grains may line up in flat parallel lines. Flat parallel lines, just like that one. Actually, that's just metamorphic rock changed. I'm sorry. Geologists classify metamorphic rocks according to the arrangement of the grains making up the rock. Foliated and non-foliated. Metamorphic rocks that have their grains arranged by either parallel layers or bands are said to be foliated. Foliated describes the thin, flat layering found in most metamorphic rocks. For instance, the crystals in granite can be flattened to create foliate texture of genesis. Oh, I was correct. So these little crystal minerals here, they get flattened and made into lines on that one. Slate is also common foliated rock. Heat and pressure change the sedimentary rock shale into slate. That is not pictured there. Slate is basically a denser, more compact version of shale. But as shale changes into slate, the mineral composition of the shale can change. Non-foliated rocks, some metamorphic, like the bottom picture, are non-foliated. The mineral grains in these rocks are arranged randomly. Marble and quartzite are metamorphic rocks that have non-foliated texture. Quartzite forms out of quartz sandstone. The weakly cemented quartz particles in the sandstone recrystallize to form quartzite, which is extremely hard. That's your picture on the bottom right here in the left. Can't find my finger. There we go, right there. The weakly cemented quartz particles in sandstone crystallize to form quartz, which is extremely hard. Quartzite looks smoother than sandstone, as shown in the picture. Finally, marble usually forms when limestone is subjected to heat and pressure deep inside the earth. Very cool. You guys can Google some of these rocks if you would prefer in your own time online. It's fun to learn about that stuff. Metamorphic rocks are used. Marble and slate are two of the most useful metamorphic rocks. Marble has an even grain, so it can be cut into thin slabs or carved into many shapes. And marble is easy to polish. So architects look at that building to the right, and sculptors use marble for many statues and buildings, such as the Tower of Pisa. Like marble, slate comes in many colors, including gray, red, and purple. Because it is foliated, so layered, slate splits easily into flat pieces. These pieces can be used for roofing, outdoor walkways, and as trim for stone buildings. The metamorphic rock, marble, and slate are important materials for building and sculpting. Thanks for listening along. Sorry it was moving so much, this video.